Hey y'all, Data Guy here. And today I have a video for you on how you can use Airflow, OpenAI, and also cloud storage and Parquet files if you want, but mainly Airflow and OpenAI to show you an end-to-end data pre-processing pipeline for ML and AI workflows. So what we're going to be doing here is extracting some documents, in this case, just financial reports from a publicly available API. Then we're going to split them into manageable vectorized chunks or manageable chunks of text. Then we're going to vectorize those chunks, use OpenAI to summarize them, and then also vectorize the summaries of those chunks so that they're available for easy ML and AI use downstream. So this is a great workflow to learn if you're figuring out, hey, I want to process large amounts of text data, but I want to do it efficiently. I want to make it easy for those downstream models to use. So that's what we're going to show here today. So without further ado, let's get into it. So the first thing we're going to do is switch over to VS Code, and you'll see here I have an Airflow environment that I have spun up. And so the way I've done this is with the Astro CLI. So if you want to do this at home, just brew install Astro. Then what you'll just do is Astro dev init. That'll create an empty folder, or Astro dev start. And so you can either do that, and I'll show you how to set up your Airflow directory to use OpenAI and everything we're using. Or you can just download this from the GitHub link in the description, your choice. So here within the setup, within our Airflow environment, what you need to do is install our Beautiful Soup package. So Beautiful Soup is basically just an open source tool that allows you to do sentiment analysis on text and web scraping. And then the other one we're going to need is this OpenAI Airflow provider, so we can actually just have a standardized way of interacting with and querying the OpenAI API endpoints. Additionally, anything else we'll need here is really just that. And also make sure you have a Postgres database available. So you see I have a Postgres PG vector database that I'm using. So this is how you can store your vectors after you have created them. So make sure you have a Postgres database available. Then to get started, what we'll do is go into create a fresh document here. So you see here I have just document pre-processing pipeline. And then we're going to, as we do with all of our pipelines, is import all the different packages we will need. So the first thing we're going to import is annotations. So annotations is exactly what it sounds like. It's just a common tool that is used to help us just have annotations within our text. Then we also have the Airflow decorators for DAG and task, just best practices to use decorators when possible. We also have the Airflow exceptions. We can raise exceptions based on different conditions. We can have more conditional logic baked into our DAG. In our pipeline, we also have params, so we can pass parameters at runtime into this particular DAG. And then you have this OpenAI hook. So this is how we're going to actually be interacting with OpenAI, is through this OpenAI provider that they created for Airflow. Then we're importing Beautiful Soup from BS4, datetime for standardized datetime. We're also going to use LangChain here. So we will use LangChain to do some document reading and text splitting. So you can see here importing document, importing HTML header text splitter, recursive character text splitter, also logging. So we can use the Airflow logs and post messages to them, import the OpenAI client. Import pandas as PD, which you can imagine is for with every data science or any kind of data work with ML and AI, you're probably going to use pandas. So we're using pandas for data frames. Pathlib, this will just make it easier to define file paths. Requests, so we can request data and process it from an endpoint. And then Unicode and UUID data just for handling unique identifiers, which we'll need to create as we process this data, so we can stamp it with a particular unique identifier so we don't run into duplicate data downstream. The next thing we'll need to do, now that we have all of our libraries set up, is define some variables. The first one is going to be the OpenAI connection ID, OpenAI default, and I'll show you how to set this within the Airflow UI in a second. We also have the logger here, which is exactly what it sounds like it's for. It is for getting loggers and just getting the logs of a particular Airflow task. We also have the Edgar headers, and so this is basically just a fake user that we're using to query the SEC database. So that's where we're getting our financial reports, is from the SEC Edgar database. And Edgar stands for something I don't know, but it's called the Edgar database, and that's what we're using here. Then we also will have our trigger rule, just default arguments, retry delay, trigger rule none failed, so just some basic trigger rule definition. And then once we're done with that, we will define our DAG. And this DAG definition will actually be interesting, unlike many of ours, in that we have some, just kind of default args, regular stuff here. But then we also have this parameters field. And this parameters field allows us to input a parameter for a given ticker at runtime and say, hey, run this DAG to get me the information for this particular company. So instead of needing to hard code this or have to update it externally and then run the DAG, you can actually just put it in right at runtime and get the information for that particular ticker that you are looking for. So really nice way of just showing how you can extend Airflow DAGs into other use cases and even to other people, because you could then trigger this from a form. You could have one of your end users just submit a form, say, hey, I want information around this company, and then you have kind of this data pipeline do the rest of the work there, which is just a really nice tool in my opinion. And so I'm a huge fan of Airflow parameters for that exact purpose, because it just allows you to democratize data, and that's what everyone's all about these days. So after we define our DAG, we're also going to just quickly define a task here that's going to remove any table tags from HTML content and just leave the actual HTML text. So all this is really doing here is just removing the HTML tags from document context. So yeah, there just isn't any text. So all the kind of extraneous formatting information gets stripped away, because we don't actually need that to determine how to figure out what the sentiment and the actual core information contained within the Edgar report is. Then the next task we're going to define is a task called get HTML content. And so this is a helper function that is supporting pandas here, which is going to scrape the doc link for any HTML contact and return any extracted plain text from the HTML without any tables. So basically what we're doing here is just downloading and processing the HTML content, and then this is going to call that remove HTML tables function that we just defined here to actually clean out all the extraneous and HTML information, and then return the raw text just as a value from the call of this particular function. So super simple process here, just basically creating a couple different helper functions that will allow us to easily clean this data for use in our downstream actual processes. Then the next task we're going to find is to get a 10Q link. So a 10Q document is just a type of financial document of the different filing details for a quarter for a company. So what this get 10Q link will do, function will do, is basically taking the account CIK number, which is the central index number for the company, and then use it to structure a query to the Edgar database here, link days, USB or URL base, CIK number, and then account number from the SEC filings index. And then what this is going to do is use it to structure a query and then get the actual filing summary of that 10Q report from using that information. Then, once we're done with that, it's then going to fetch and parse the document index page to find the link to the actual 10Q document and get us that link for that particular 10Q document. So this is basically structuring the query that will then allow us to access that underlying 10Q document. Then, now that we have that 10Q link, the next function we're going to be defining is quite a doozy. So we'll go through it real slow. I'm just going to put it all here right now, and that is the task of actually extracting the document. So here, starting all the way at the top, document extract. So this task is taking the 10Q date documents for a given ticker symbol from the SEC database, Edgar database, and then this is going to use all those functions we just defined to clean that data, make it usable, and then create a data frame with links to the documents and their metadata. So here, extract, see it's going to take in the ticker, CIK number if you don't have the ticker symbol, and then it's going to return us a clean data frame. So here, extracting documents for ticker, so just adding a message to the log so we know that this is the right ticker for the documents we're getting. Then the next piece is getting the company list, querying the company tickers JSON file. If the company list equals okay, then we're going to get the different CIK numbers, provided ticker number isn't available, make sure that this is actually a valid ticker, and then otherwise could not access the ticker database. Then once we verify that it's valid, we're going to then file a request get to get the company facts for that CIK. And from those company facts, we're then going to get the actual 10Q information here. So you can see forms 10Q, and then for fact in company's fact, USG AP, which is what contains the actual company facts, we are going to basically append them into a 10Q form. And this 10Q form is just going to gather all the information contained within that particular 10Q ticker. So it's going to have all the different links to the different documents that comprise that. So you can see here for every unit, and this is, if you go look at the underlying data, it kind of makes more sense, but it's basically just saying, hey, for each segment within this JSON, get the 10Q for that particular quarter and that quarterly report. Then we're going to drop any duplicates, save all that information to a database with the account number, and then we are going to also just define some error messages if it wasn't able to get company filing information. And this will just give us back the status code and the reason here as well. Then once we're done with that, we can create a docs dictionary. And then so for every link in that 10Q link folder we had, we're going to get a 10Q link, get the information from that form.get, and then we're going to append it to our docs database, which is going to have the doc link to that particular 10Q report, the ticker number, the fiscal year, the fiscal period, because each 10Q corresponds to a fiscal period of a year. So there's core 1, 2, and 3, 4. That's going to be 4 10Qs per year. And so this fiscal that year, or form.get for fiscal year. So what FY is and FP. So getting just the fiscal year and fiscal period for that particular report. And then saving that full docs dictionary as a data frame. And then what we're going to do is use a mapping lambda function to actually get the HTML content for each of those doc links. So remember up here, we have our get HTML content, which scrapes each of those doc links for the actual content contained within that 10Q report, and then is going to add this all into this pandas data frame, dropping any A's, duplicates as well. So now we have all of our raw data contained within this data frame here, ready to be used in some more downstream tasks for actual pre-processing. So we have the raw text data, but now we actually need to we need to chunk it up and then turn it into vectors. So the first task we're going to need to run to start processing this data is actually splitting all of our data. So to do that, what we'll need to do is start this splitter task. So here, this split task is going to split the document content into multiple manageable chunks for further processing, as I discussed. And it's going to use HTML header tags to split the docs initially. Then it's going to further split the text into smaller chunks using a recursive character text splitter. And so the way this recursive character text splitter works is basically it'll say, hey, for this size, find these natural separators like a space with this -n, so new lines, double new lines for new paragraph, and then also spaces like just having a space, having a comma, things like that. So these are kind of the identifiers for, hey, this is what might logically separate text. And what this means is like, hey, you're typically going to have a new space between a paragraph. You're going to have a period or a new line for a new sentence. And so what this will do is try to split based on those parameters with the maximum chunk size of 10,000 characters, chunk overlap, maybe 200 characters. So two different chunks can have 200 characters of the same context if it's relevant to keep that information within that chunk. So you have kind of the entire chunk at once instead of splitting relevant information that, kind of corresponds to each other into multiple different chunks. The recursive text character splitter will try and avoid that and keep, like a paragraph about the queen all together. Then after we're done kind of defining what our recursive text splitter is and our HTML header splitter, we're going to apply them to actually split the text. So here we're going to take document chunks and apply the HTML splitter. So just split it by different pages, which is what that HTML header will contain, is what page this was on. Then it's going to explode it again, and then also apply the X by page content. So here we're basically just replacing the previous content with the doc chunks, and now it's been chunked. Then we're going to take the chunks of that we've just created and then run this split documents to actually just split it based on page contents, bring it out again, and then we are going to just use the text splitter to say, hey, based on this recursive text splitter, save it as data chunks. Then what we're going to do is add this doc chunks to our data frame and then replace the previous content field with the doc chunks. So now our content is the chunks that have gone through both the HTML splitter and the text splitter. Then we're just going to drop doc chunks because we've saved all that information within the content or the content column. Then we're going to drop any duplicates and reset the index as well. So basically just splitting it twice, saving the chunks as content, then splitting that content again. And chunks just kind of acting as a temporary table here for us to split the content in before saving it back into that content column. Sorry, a lot of C words here. So now that we have all of our data chunked, it's all in various chunks within the content column. The next step is to take this chunked up pre-processed data and actually vectorize it. So that'll be our next task, is vectorizing. And this is where we finally use the OpenAI embeddings tool. So within this vectorized task, what we're going to be doing is just converting those text chunks into vector embeddings, which are kind of numerical representations of text and sentiment, using the OpenAI embeddings model, which will make it easier for AI and ML models to actually consume that information and use it for, finding correlations, finding, identifying patterns within that data. So it's going to iterate over each text chunk, generate an embedding using the OpenAI API, and then save those results to a Parquet file. So you could also save this into an S3 bucket or whatever. I'm just going to save it locally for now because it's just going to be a little bit easier. So here under vectorize, we're going to concatenate multiple data frames from those upstream dynamic tasks and then vectorize them with the OpenAI embeddings. So here with our OpenAI hook, so this is just basically going to tap for every individual split ticker that we put in, or actually every chunk of every document that we're going to put in. So here we have our OpenAI hook using the OpenAI connection ID, data frame ID equals data frame column name, and this is the data frame that we just created of the different document chunks here. So here, what we're going to do is apply lambda x namespace, so add a UUID, so a unique identifier to each chunk. And then what we're going to do is vectorize. So here we're going to have our content column name, which is, again, just the content column name from this previous task. We're going to apply the create embeddings OpenAI API endpoint to each of those chunks. So here the text embedding a.002. What this will do is just for each of those chunks, call the OpenAI endpoint, have it generate a vector embedding for that endpoint, and then save it within this data frame as a vector. Then after that, we're just going to run a quick dfeed to Parquet, df to Parquet with the output file name, and this is just going to basically just save a file in our local file system. And again, we actually haven't set this before. So set that to whatever you would like it to be, wherever you want to save that eventual file. So after we're done with that, our next step is to chunk the summarization of those. So we have our vector embeddings. Now it's time to use them to actually generate some summaries. So what we'll do here, and this is kind of a test of the accuracy of our embeddings and whether or not this actually worked, was saying, hey, let's feed these chunks into OpenAI and then use the GPT 3.5 turbo model to actually summarize that chunk of text. So we're giving it that content that we defined previously. We're giving it a ticker, the year and period we want to summarize for. And then what we're going to do is feed that into the chat completion here, so OpenAI chat completion, giving it the content, which is, again, what's coming in as a string, so the string from the previous chunking within the previous vector task, and it's going to fill that in. So say, hey, using this prompt, I'd like you to read the following text and summarize it into a concise paragraph. And there's some more just definitions of what it's going to do. And then give me a response, giving me a summary of that paragraph. So what this should do, or what this will do, is take one of those chunks and then summarize it for us. And then it also has the option, and then the next option we're going to create is the option to summarize the entire document. So here, we're not only going to give it just a single chunk, but we're going to actually feed in every piece of document that we want to summarize. So this is actually going to require GPT-4. So if you'll just need to have access to GPT-4 and endpoint. I have an OpenAI Pro account, so I'm able to. And then so here, OpenAI client, content, doc link, all things we previously defined. And then so here, what we're going to do is basically give a URL to the document that we want to be summarized, which will be that 10Q URL before. And then what this is going to do is just summarize the information for that link. So we have content coming in as that string of that document. And then what this is going to do is just go through and summarize all the content contained within that document. So it's going to iterate through those chunks and then give us a final summary of what the sum of those chunks contained. Now, finally, bringing us to the max level is going through all the documents for a given ticker. So not just a single 10Q report or a single paragraph, but actually recursively summarizing all the extracted documents. So here, what we're going to do is bring in a new task called Summarize OpenAI. And what this task will do is basically orchestrate this, the summarization process, applying the summarization functions to the data frame containing the document chunks, and then combining the chunks into the summary chunks into document summaries. So here you can see we're using that OpenAI hook, feeding in our pandas data frame that contains our different document chunks. Then what we're going to do is apply that chunk summarization OpenAI to a given document. So here we're feeding it, a particular chunk, fiscal year, fiscal period, ticker, whatever we want. And then this will take it, pass it into our chunk summarization function here, and then the result will be a summary of that individual chunk. Next, we're going to group by document link. So all the documents that have the same document link, which all chunks that have the same document link, which will correspond to that single 10Q report, summarize them and apply just a join to join all these different summaries together into one summary of chunks. Then the next thing we're going to do is take all those different chunks, so the chunk summary that we just created, and then feed it into our document summarization OpenAI function. And this will take all those different chunks, all those different summaries of the different chunks within a document, add it to all the different documents for that particular company, so all the different 10Q reports, and then provide us a summary on top of all of those the entire document as a whole, so not just a single chunk. Then we're going to drop the chunk summary because we just want an overarching summary of the entire document. And then we are going to drop any duplicates, merge it into our summaries data frame. And so here we're just dropping content and chunk summary because we no longer need them here because we have the information stored under the summary. So we don't want to actually have to save all that really large volume content data. So now we have a full pipeline that will take a raw series of documents, chunk them up into different manageable chunks, then create summaries of those chunks before then summarizing the summaries of all those individual chunks. So now it comes time to just actually define the relationships here. So here, task extracts, we're using the task API to just change that extract task into an actual Airflow task. So Edgar docs, ticker equals ticker, split, and then this is taking the information so we get from that just Edgar docs extract, splitting it into the chunks. Then we are passing the into a task which is going to be vectorized. So here we have this vectorized task up here, which is then we're going to feed it in the output file name, so that Parquet file we're going to save locally, column name, and then split documents there. Then next, what we're going to do is generate a summary. So use that summarize OpenAI task, feed it in those split documents to actually generate our summaries based off of the chunks and the chunks of the chunk of the summary of the chunk summaries. Then we have the summaries file where we are going to again use the vectorized task, task ID summaries, output file name, column name summary, generate summaries. So using the same underlying vectorized method here, but using it for two different use cases. So this just makes that one single function able to be used within two separate locations in the DAG. So we can vectorize in different ways, whether we want it to be vectorized based on vectorize the chunks or vectorize the actual summaries for further embedding use. And then what we'll just do is add finsum OpenAI ticker equals blank, and that just initializes our DAG with that ticker as the parameter that we can use to trigger it. So now it's time to go into the Airflow UI and see this all work and come together. So within the Airflow UI, before you actually run this, you're going to need to go to your connections tab and then add a new OpenAI hook. So OpenAI, and then all you're going to need to do here, so let's just call this, what did we call it within the task? We used OpenAI default as our connection ID, and then you're just going to paste in your API key here. So I'm going to get my API key posted in here, and then I'll meet you back at the DAG run page because that's all you need. It's just an API key. And so here, after a relatively long time, I mean, it's doing a lot of ML work, and it's just doing it on a local machine, so it took a little while here. But if I go to summarize OpenAI, you can see the return summaries of each individual document, doc link, and summary here. Which is exactly like we expected. We wanted to get a summary of each of these individual chunks. And you can also go to vectorized summaries to look at the overall vectorization summary, go to split here to look at the split of the actual raw underlying values. And you can see how the summary really makes this a lot more human readable. I don't know about you, but I find this much more readable than this. So super useful flow here, really useful data pipeline to put in your toolkit and maybe implement in your own company. I hope you found this useful as I did, and I hope above all you have a great rest of your day. Data Guy out.